Right, in this tutorial, I'm going to show you the basics of how to get started with kind of the trendy new thing right now, which is called augmented reality. So if you don't know what that's all about, let me just show you an example. This is a site created for GE about renewable energy. And if I launch this wind turbine application, you can see it's asked me for a webcam. And once we load, there's the webcam data. So now if I print out this pattern from their site, we can see here on the right, I can print out this pattern. And when I hold it up to my webcam, we can see this 3D scene is actually being mapped onto that pattern. And we can see the sun is moving here. It's just a really cool thing. So this augmented reality is an ActionScript library used in conjunction with PaperVision 3D to allow you to map 3D objects onto these patterns. And I'm going to show you how to get started with that. So the first thing you need to do is to actually get the libraries. So you want to go and use Subversion. And if you don't know how to use Subversion, you should definitely learn how, because most Flash libraries are distributed using Subversion. So for the FLAR toolkit, that's what it's called, the Flash Augmented Reality Toolkit. This is the, let me go here. This is the actual SVN URL to get the toolkit. So libspark.org, SVN, AS3, FLAR toolkit. And when you check that out, you essentially have a libspark folder, and that you need to put into your global ActionScript directory. So in mine, it's under org. So you want to bring in that libspark folder right there, and that actually contains all the classes for the FLAR toolkit. Now the other thing that you need to get is PaperVision 3D if you don't already have it, and this is the actual SVN URL for PaperVision 3D, and you want to get PaperVision 2. So inside of that you have all the PaperVision classes that you're going to need. So using these two libraries together is what allows you to create the augmented reality. Again, the FLAR toolkit is the thing that actually detects the pattern and maps on your 3D objects. Okay, so another thing you're going to need to do is to download a little AIR application. Now this AIR application is what allows you to actually capture a certain pattern. So and I'll show you what that is in a second. So really good blog that I got a lot of the information about doing this is Mikko Hapoja. Hopefully I'm pronouncing his last name correctly. In this blog post, he actually has a lot of information about the various pieces of setting up an augmented reality project. But you want to come down to here, to the marker file, and download this AIR application. And essentially this AIR application is basically the application that will allow you to capture whatever pattern you create for use in your application. So I already have it installed. So let me launch that. It's called the AR Toolkit Marker Generator. And here again is the webcam. Now these patterns you can actually create, as long as it has that black rectangle. You can create anything you want inside of there. So for the GE site, they have this little solar panel and a sun. Now you could, in Photoshop, create anything you want on the inside of this black rectangle. For this example, I'm just going to use the pattern from the GE site. So all I have to do is to hold it up until I see the red rectangle around the pattern. And now I just click Save Pattern. And now I can save this pattern file. And I'm just going to save it to the desktop. I'm just going to call it pat1.pat for pattern. I already have it there. I'll just replace it. And there's my pattern file. So now essentially this pattern file I'm going to need to include in my project so that the FLAR toolkit knows the pattern to detect for. Okay, so let's go ahead and get started. I'm going to create a new ActionScript project. I'm not going to use Flex. I'm just going to create a pure ActionScript project, and I'm just going to call it FLAR Demo. And click Next. Now for source path, I'm going to give the folder to my global ActionScript directory, which I already have here. So I'll just click choose. That's going to import all those, the FLAR toolkit and Papervision into my project. Okay, so here's my root application. Okay, so now what I need to do is I actually need to embed that pattern file that I just created. So all I'm going to do is drag it from the desktop into my source folder here so that I have it there. Now I need to create a private property for that. And I have it as a snippet to do an embed. And the file is called pat1.pat. And for the actual class name, I'm going to have it be pattern. Okay, so this is the format here. It's just like embedding an image or anything else in using Flex metadata. Embed source equals pat1.pat. Put this MIME type. And now anytime I want to use it, I use the name pattern. So this is essentially being stored in this class. Now there's actually one other file that we need to embed, and this is the camera parameters file. Now it doesn't really matter necessarily that you understand what's going on inside of this particular file. If you look in the FLAR toolkit, we can see here under samples, if you go into the data folder, this camera par.dat. So let me see. All I'm going to do is to drag that also into my project source folder. So this is a binary file that actually contains various things for correcting lens distortion on the webcam data. But again, you don't really have to know what this file is all about. So all I'm going to do is I'm going to do another embed here. And this one is camera_par.dat. And for the actual name here, I'm just going to call it params. Okay, so now I've imported those two files that I need to make the FLAR toolkit work. Okay, so inside of my constructor, all I'm going to have in my constructor is a series of method calls that are going to set up my project. So the first method is going to be called setupFLAR, and this is going to set up my augmented reality project. So I'm going to create a private function called setupFLAR. Okay, so now what I need to do is I need to set up these two files that I've embedded in my SWF. So what I need to do is create two objects. One is an instance of the FLAR param class, and the other is an instance of the FLAR code class. So I need to create some private variables for those. So I'm going to give the params a name of fparams. Oops. And this is going to be instance of the FLAR param class. And the next one I'm going to give a name of mPattern. And this is going to be an instance of the FLAR code class. Okay, so now that I have those private properties set up, now I can actually create them here inside of my setupFLAR function. So first I'm going to create fparams is equal to new FLAR param. Okay, now I need to actually load in this parameters file into this FLAR param instance. So all I have to do is say fparams, and then I want to call the load AR param. So now this is asking me to pass in that binary file, which is held in this class called params. So all I have to say is new params, and I need to cast it to byte array since it's a binary file. Okay, so that sets up the parameters file. Now I need to do the same thing for the pattern file. So mPattern is equal to new FLAR code. Oops. And then here I just need to pass in two numbers, which are essentially the resolution of this pattern. Now, again, you don't really need to worry about this. It seems from my experience that everyone's passing in 16 for this. To be honest with you, I don't even know why, but I'm just going to go with what everybody else is doing, and it seems to work. So again, you can check out Miko's blog for more information about this stuff. And now again, I need to load the pattern into this FLAR code instance. So I'm going to say load ARPat, and now just create a new instance of pattern. Okay, so this is the kind of the setup for the augmented reality project. We have these two files that we need to include. The pattern file, which defines that pattern that we captured using that AIR application. And then the camera parameters file, again, which you don't really need to know what's going on with that. You just need to embed both of these files, and then this is how you set them up. So essentially, that's how you set up the FLAR part of the project. Okay, so the next method we're going to call is setup camera. Now this is going to set up our webcam, since obviously we're going to need a webcam in this project. So setup camera. Okay, so now inside of here we just need to do a basic webcam setup. So what I want to do is to create a new private var, and I'm going to call it vid, and this is going to hold an instance of the video class. And now we want to create a new instance of the camera class. I'm just going to call it cam. This is going to be instance of the camera class. So now we can go down and start setting up our camera. So vid is equal to new video. Now for this, we're going to make the video 640 by 480. And at this point, it's a good time to actually create our Swift metadata for this ActionScript project, which is going to control things like the frame rate and size. Oops. So I have this already as a snippet. So this is just the Swift metadata that says width and height, frame rate, and background color. So we're going to create our video object 640 by 480. Now let's set up the cam. So cam is equal to new camera. And actually, no, it's not new camera. We want to use the static camera.getCamera method, and we can just leave it empty like that. That should work on most systems. Okay, now what we need to do is to set the mode of that camera. So when we set the mode of the camera, we're setting things like its size and frame rate. So all we have to do is say cam.setMode. We want it 640 by 480 at 30 frames per second. That's going to give us a nice crisp picture, and the frame rate's going to help us to make it more snappy when our 3D object is attached to it. Now we just need to actually attach the camera. So vid.attachCamera, cam. And then lastly, we just need to add the video component to the stage. Oops. Add child, vid. So let's test what we have right now, and we have an error. So let's see what it's saying. Let me open up the errors panel here. Okay. This is params. Let's try that again. And here we can see our webcam application. If I click allow, we can see the webcam. So what I'm actually going to do is to have this pop up in Flash Player, not in the browser. So I'm going to go to Properties in my project and go to Compiler, and I'm going to uncheck Generate HTML Wrapper. That way it's just going to launch in Flash Player, which I prefer for something like this. So there's our webcam setup. Okay, so the next thing we need to do now is to actually set up the bitmap data. So obviously what we're going to be doing here is on every frame we're going to take a bitmap data shot of the webcam, and we're going to pass it to the FLAR toolkit. And then the FLAR toolkit is going to try to detect our pattern in that bitmap data. So I'm going to create a new method here, setup bitmap, and come down, setup bitmap. Okay, so what we want to do here now is to create a new instance of the bitmap data class. So let's go up to the top here and BMD is of type bitmap data. And let's go ahead and create that new bitmap data object. So BMD is equal to new bitmap data. And we need to give it its size. So 640 by 480. Okay, so now let's go ahead and just draw it initially. So BMD.draw, and we want to draw that video object which contains our webcam feed. Okay, now there's two other FLAR objects that we need to create. So this is actually, these classes are what's going to enable us to detect our pattern. So let's go up to the top here, create another private variable. And this one I'm going to call raster. And this is going to be of type FLAR raster underscore bitmap data. And the next one we need to create, I'm going to call detector. This is the class that's actually going to detect whether the pattern was found. And this is going to be of type FLAR single marker detector. So there are ways to actually detect multiple markers to create, even more complex applications. But we're going to stick with just the single one here. So now I can go back down to my setup bitmap class, and let's go ahead and instantiate those two. So raster is equal to new FLAR raster underscore bitmap data. Now to this we actually need to pass in the bitmap data object that we want to capture. So BMD, and now let's set up detector is equal to new FLAR single marker detector. And now to this we actually need to pass in first the params object that we created, which is being held in f params. Then we need to pass in the pattern that we created, which is being held in m pattern. And then lastly, we need to put in the marker width number, and I'm just going to put in 80 for that. You can experiment with that, but that's essentially the width of the marker. Okay, so now that I've set up this stuff, now is the point where I can actually start doing some PaperVision 3D stuff here. So again, this setup bitmap has set up the bitmap data object, and it has allowed me to actually, wait, I have an error here, so let's see what this error is all about. Oh, I believe we have the wrong class here. Yeah, this is supposed to be not FLAR raster underscore bitmap data. This is supposed to be FLAR RGB raster underscore bitmap data. So that's the problem here. Okay, so let's go ahead and change this. It's equal to new FLAR RGB raster underscore bitmap data, and then pass in the bitmap data object. Okay, there we go. Okay, so now I've set this up. Again, I have my bitmap data here, and I'm going to be drawing that video object. And again, we're going to be doing it in an on-enter frame, obviously. And then I need to create this FLAR RGB raster underscore bitmap data. This is going to hold our bitmap data in the FLAR toolkit. And then this detector, and this is going to use the camera parameters file and the pattern file we created from the AIR application, and it's going to try to make a match. Okay, so now let's actually go ahead and create our PaperVision 3D scene. So for this, I'm going to create another setup method called setup PV3D. And let's go ahead and create this. And again, once you have all this code set up, you can just use it as a template for future applications. PV3D. Okay, so what we want to do in here is we want to set up our PaperVision 3D scene. So let's go ahead and create the private variables we're going to need for that. So first thing I'm going to do is create a variable called scene, and this is going to be of type scene3D. The next thing we want to do is to create another private variable. I'm going to call this camera. Now we're not going to use a typical PaperVision 3D camera. So the trick is here we need to create an instance of the FLAR camera 3D. So it's very similar to a PaperVision 3D camera, except this is specific to the FLAR toolkit, and it will allow us to detect our patterns. Okay, now the next thing we need to do is to create a 3D container that's going to hold any 3D objects that we want to map onto that pattern. So I'm going to create another private variable. I'm going to call it container. Now this needs to be of type FLAR base node. So this is the actual container where we're going to add our 3D objects. And since it's in this FLAR base node class, it's going to work correctly with the augmented reality classes. Okay, so I have my scene, my camera, my container. The other thing I need to create is a viewport. So I'm just going to call it VP. And this is going to be of type viewport 3D. And the last thing I need to create for PaperVision is the rendering engine. And I'm just going to create a basic render engine. So I'm going to say BRE. Okay, so now I've created these classes. Now we can start setting up PaperVision. So let me collapse these methods. Okay, so the first thing I'm going to do is to create that scene 3D. So scene is equal to new scene 3D. Oops, what happened there? Scene is equal to new scene 3D. Now let's create the camera. Camera is equal to new FLAR camera 3D. And to this we need to pass in that camera parameters file that's held in the params class in an instance of fparams. So let's pass that in there. Okay, now we can go ahead and create the container. Container is equal to new FLAR base node. Okay, so now we have our 3D scene. We need to add the container to that 3D scene. So all I have to do is say scene.addChild and pass in container. So again, you can think of FLAR base node as just an extension of a typical display object 3D from PaperVision. Okay, so what we're going to show actually in this application, we're not going to do anything obviously as crazy as that GE one. We're just going to show 3 cubes stacked on one another in Z space, and we're going to map that onto our pattern. So first thing I'm going to do is to create a light so that we have some nice shading. So I'm just going to create a point light called PL, and this is of type point light 3D, is equal to new point light 3D. Oops. And now we need to position this so that we actually get some nice shading. So I'm going to say pl.x is equal to 1000, pl.y is equal to 1000, and pl.z is equal to negative 1000. This is going to position it so that we actually see some nice shading on our cubes. Okay, so now we have the light. Now we need to create a material that we're going to apply to those cubes. So I'm going to create a flat shaded material, but since it's a cube, we're going to create a materials list first. So var, I'll just call it ML, is of type material list. It's equal to new material list. And what we do here is, oops, yeah, one thing, let me pull that in. Okay, so now we actually need to pass in an object where we say which material is going to be on which side of the cube. But so we need to pass in an anonymous object, but if we want the same material to be applied to all sides of a cube, we just say all, and now pass in a material. And we're going to use a new flat shaded material. And to this, we just pass in which light do we want to use to shade it. I'm just going to pass in that point light that we just created. And I can close the anonymous object and the material list here. Okay, now I have my light and I have my material. Now I can just go ahead and start creating the cubes. So let me come here. I'll say var cube 1. Oops. Is of type cube. It's equal to new cube. And now here on the cube, we need to send in the material list that we want to use. I want to use ML. And then the width, depth, and height. And for all of these, we're going to put 30. Okay, so I'm going to keep the cube 1 actually at the origin so we don't have to position it. So I'm going to paste this in twice. This is going to be cube 2 and cube 3. Now for cube 2, I actually want to bring it closer to the camera in Z space. So I'm going to say cube 2.z is equal to 50. And for cube 3, I'm going to do something similar. Cube 3.z is equal to 100. So this is going to stack them so we get a nice stacking effect. Okay, so now that I have these 3 cubes created, I need to now add them to my container. So I say container.addChild cube 1. Let me just copy that. Add cube 2, and then add cube 3. Okay, and now I need to set up my basic render engine. So BRE is equal to new basic render engine. Okay, now the last thing that we need to create here for the FLAR toolkit is an instance of the FLAR trans mat result. So this is essentially what's going to a class that's going to receive the transformation object that we can apply to our 3D scene. So the FLAR toolkit is going to detect our pattern and determine where it is in 3D space, and then it's going to send us back this this transmat result that we can then apply to our 3D scene. So I'm going to go up and actually create a private property for this, and I'm going to call it trans, and this is going to be of type FLAR trans mat result. So let's create this here. Trans is equal to new FLAR trans, new FLAR trans mat result. Okay, now to finish up our PaperVision 3D stuff, we now need to create the viewport. So VP is equal to new viewport 3D. And this is going to be of size, actually 640 by 480 is the default, so I'll just leave it like that. And now, finally, to finish the PaperVision, we just need to add our PaperVision viewport to the display list. Okay, so again, this project is definitely a little bit complicated when you're starting out with the FLAR toolkit. But again, once you have this basic template set up, it's basically just reuse it with different patterns and different 3D objects. You can obviously see if I wanted to have a different 3D scene mapped to my my pattern, I just put in some new, maybe import a Collada file or something like that. Okay, so now we've set up PaperVision 3D. Now we need to actually create the onEnterFrame event, which is going to do all the work. So it's going to go out and detect for the pattern, and then it's also going to manipulate our 3D scene. So I'm going to put that here right under Setup PaperVision 3D. And this is just going to be add event listener, event.enterFrame, and we're going to have it call a function called loop. So we can go ahead now and create this scene, or create this event handler rather. And it's called loop. Okay, so the first thing we want to do on every frame is we want to capture the bitmap data of the webcam. So all we have to do is to say bmd.draw, and we want to draw that video object. So that way we have it stored inside of our bitmap data. Okay, so now to actually do the detection, we want to create an if statement, and we say if detector dot detect marker light, and why it's called detect marker light, I don't know. But essentially here, what we're going to do is we're going to pass in, let me open this up, this raster object that we created. Again, this raster object has the bitmap data in it, and this is how we send it to the FLAR toolkit. So I'm going to pass in raster, and now we pass in a number for the threshold. Again, I'm not positive what that does, doesn't matter. If you want to find out more, go and look in the source code. But for me, I'm fine with not really knowing as long as it works. So I say if detector marker light raster is of a threshold of 80. So this is the number essentially you can tweak for how accurate this is going to be. And detector dot get confidence is greater than 0.5. So obviously what this does is this is essentially the confidence level that the FLAR toolkit has that it's actually found your pattern. So again, you can tweak these values, but again, based on the examples that I've seen, you can just leave these at their defaults, and they work really well. Okay, so if those two conditions are true, now what we need to do is to get the transformation data from the FLAR toolkit and apply it to our 3D scene. So first I'm going to say detector, and I'm going to call the get transform matrix, and now we pass in our FLAR transmat result object, and then now we say container set transformation or set transform matrix, and now we pass in trans. So essentially this line right here has gotten the transformation matrix and stored it in trans, and now we're setting the transformation matrix of our container to those values. And now the last piece is just a Paper Vision 3D thing that we need to do. We need to tell the basic render engine to render our scene. And here we need to actually pass in the scene, the camera, and the viewport. Now, one thing based on my testing is we sometimes get runtime errors, and one easy way to do it is if we wrap this if statement inside of a try catch. So there's probably events that you can respond to, but for my case, all I'm going to do is just wrap it in a try catch so that it will catch any runtime errors that happen. So I'm just going to say catch error, and then I'm not going to do anything with the results there. Okay, so let's see if we have any errors. So it doesn't look like we do right now. So let me just run through really quickly what we've done here. And again, it's not important that you necessarily understand every aspect of this, but the main thing, the brains of the FLAR toolkit are these two files, this camera parameters file and then your pattern file. And again, your pattern can contain anything inside of the black rectangle, and you use that air application to create this file. So we embed them both into our project, and we set up some classes so we can actually use them. First, we set up the actual FLAR toolkit. So we create a new FLAR params and FLAR code classes, which basically load in these two files into the toolkit. Then we create simple webcam and add it to the display list, so we can actually obviously capture the webcam data. Then we need to set up the bitmap data here. So new bitmap data, which is drawing the video object. And then these two files are the FLAR toolkits files. First is this raster file, which holds our bitmap data. And then the actual detector, the FLAR single marker detector, which is the class which is actually going to detect whether this pattern has been found. And then we go through and do a typical PaperVision 3D setup. So if you've done PaperVision before, this will all be familiar to you. The only differences are, instead of a regular camera 3D, we use a FLAR camera 3D. And then instead of a regular display object 3D to contain our scene, we're using a FLAR base node. So we create a light, we create a material, create 3 cubes and offset them on the Z. We add them to the container. We do the rest of our 3D setup. We create this FLAR transmat result, which is to hold the results of the transformation. And then in the loop, we draw the bitmap data of the camera. Then we use this if statement, and we first detect if the pattern is there, and then the confidence level of that detection. And again, you can tweak these. Then now what we do, if that is true, we get the transform matrix from the FLAR toolkit and apply it to our 3D container, and then just render our scene. So let's go ahead and fingers crossed this will work. So now I have it here. I'm just going to allow for my webcam to be seen, just like that. And now you can see we have our 3 PaperVision cubes that are being mapped onto this pattern. And we can see the results are, pretty much just as good as they are in that GE demo. I can move this. Let's see how far back I can move this. So you can see it's pretty accurate here as I come in. And we can see those cubes are stacked in Z space. So basically now all you have to do is, if you want to create some more complicated models, like again importing Collada files and things of that nature, all you have to do is just replace the objects that you actually are putting into your PaperVision 3D scene. So again, this code takes a little bit of getting used to, but as I mentioned before, just save this out as a template, and then all you have to do is to change the easy things, which are the properties of your PaperVision scene.